Okay, today we'll be going over recursive functions for the ACSL contest number 1. So let's start with how a normal function works, a non-recursive function. So here we have f of x, where f of x is equal to x squared. Well, if we wanted to do f of 4, we simply plug in 4 as x, and we get 4 squared, or 16. Similarly, g of x is a function that's equal to f of x plus 2. Well, g of 4, we're simply going to plug in 4, and we'll get f of 4 plus 2. To find out what f of 4 is, we just need to go to the function f of x and plug in 4, which we know is going to be 16. So we get 16 plus 2, or 18. Finally, we have h of x, which is a recursive function. Just like g of x called f of x, h of x calls itself. Functions that call themselves are recursive. So here we kind of have an if statement going on. If x is greater than 2, then we will go to this condition and h of x will be equal to this. If x is not greater than 2, then h of x will be equal to 0. So let's try this with h of 4. Well, h of 4 is going to be equal to h of 4 minus 2, or 2, plus 1. And then to find out what h of 2 is, just like we did earlier, we're just going to plug in 2 for h. So h of 2, that's going to be equal to 0, because 2 is not greater than 2. So we go to the otherwise statement. Therefore, we can just substitute 0 here and get 1. h of 4 is 1. Cool. So now let's look at a classic recursion situation. So a Fibonacci sequence is where each number is equal to the previous numbers added up together. So the first two numbers are just defined as 0 and 1, and from there you can just add up the previous two numbers. So 0 plus 1 is 1, 1 plus 1 is 2, etc. So let's find out what the fifth Fibonacci number is using this function. Well, the way this function works is that if x, or the x Fibonacci number we want, is less than or equal to 1, then as a result we will just get x, because because the 0th Fibonacci number, I guess, is 0, and the first Fibonacci number is 1. After that, we just do f of x minus 1 plus f of x minus 2 to get the previous two numbers. So let's find out what this looks like with f of 5. So f of 5 is going to be equal to f of 4 plus f of 3. And let's find out what f of 4 and what f of 3 are. So f of 4 is equal to f of 3 plus f of 2. And let's do f of 3 next, which will cover both here and here. Well, that's just going to be f of 2 plus f of 1. Scroll down a little bit. Now let's find out what f of 2 is. We can cover these two numbers. So f of 2 is going to be f of 1 plus f of 0. And now let's cover f of 1 to cover these two cases. Well, 1 is less than or equal to 1. So we're going to just get 1 as a result. And similarly, f of 0 is going to be 0. Now we can go back up and kind of fill in the blanks. So f of 1 is 1 and f of 0 is 0. So this is going to be 1. So this is going to be 2. So this is going to be 3. And this is going to be 5. So the fifth Fibonacci number is 5. Okay, so if you think you've got it from here, you can totally stop watching this video, but I'm going to go over some sample problems from the ACSL wiki. So let's look at this problem, where we need to find g of 11 given this equation for g. So if x is greater than 0, then g of x is equal to g of x minus 3 plus 1. And if x is not greater than 0, then it's just going to be equal to 3x. So let's do this to find g of 11 as the question asks. Okay, so g of 11 is going to be equal to g of 8 plus 1. Let's find out what g of 8 is. Well, g of 8 is going to be equal to g of 5 plus 1. Let's do g of 5. Well, 5 is still not greater than 0, so we're going to go to g of 2 plus 1, and then g of 2 is going to be equal to g of negative 1 plus 1. Let's make those two ones the same. Okay, so now that we have g of negative 1, we finally reached the condition that gets us to the base case, the case that's not reliant on calling itself as a function. So here it's going to be equal to negative 3 because negative 1 is not greater than 0. And we can kind of go back up the chain. This is negative 2, negative 1, 0, and 1. So g of 11 is going to equal 1. Alright, next let's do this problem where it defines h of x as h of x minus 7 plus 1 when x is greater than 5. It's going to be x when x is between 0 and 5, and it's going to be h of x plus 3 when x is less than 0. So our base case here is going to be this one because this case is not reliant on calling h again. So let's begin. So 13 is indeed greater than 5, so we're going to do h of 6 plus 1. So let's find out what h of 6 is. Well, 6 is still greater than 5, so we're going to do h of negative 1 plus 1. And to find out what h of negative 1 is, well, negative 1 is less than 0, so we're going to do h of 2. And 2 does fit this condition where it's where 0 is less than or equal to x is less than or equal to 5. So h of 2 is just going to be 2. Let's go back up the chain. So this is going to be 2, this is going to be 3, and this is going to be 4. So there we go. Alright, now let's move on to the last, not the last problem, actually just one more. The second to last problem, which is f of 12, 6, where f is defined, f of x, y is defined as f of x minus y, y minus 1 plus 2 when x is greater than y, and x plus y otherwise. So here you're just going to treat it like any other function, even though there's multiple parameters. And in this case, yes, 12 is greater than 6. We're going to go through the first case. So we're going to get f of 6, 5 plus 2. Next, let's find out what f of 6, 5 is. Well, that's going to be x is still greater than y, so we're going to be doing f of 1, 4 plus 2. Okay, this time x is not greater than y because 1 is not greater than 4, so we're going to do x plus y, which is 5. Then we go back up the chain, we get 7, and we get 9. So the answer to this problem is 9. Okay, now let's look at the final problem. So we have the following algorithm for painting a square. Given a square, if the length of a side is less than 2 feet, then stop. Then we're going to divide the square into 4 equal sized squares if the length of the side is not less than 2 feet. We're going to paint one of these small 4 squares, and we're going to repeat this procedure for each of the 3 unpainted squares. So let's do it for a 16 by 16 square. So here's my square. Let's go through each of the steps. So yes, you're given the square. If the length of the side is less than 2 feet, stop. Well, it's 16 feet, 16 is not less than 2. We're going to divide the square into 4 equal sized squares, very clumsily. And we're going to paint one of the small squares. So let's just paint the upper left corner. Now we're going to repeat 1 through 4 for each unpainted square, and while we're at it, why don't we keep track of what we have painted so far. So this is going to be an 8 by 8 square, so that's going to be 64. Sorry, let's write it over here. So we have a 64 feet squared square colored in. Okay, cool. So now let's do this same thing for the rest. Well, each of these squares, oh right, I forgot to go through this step. Well, each of these squares has a side of 8, and 8 is not less than 2, so we're going to divide it again, which I already did, and we're going to paint each of these small squares in the upper left corner. Well, each of these squares is going to have a side of 4, right? So each of these squares is going to have an area of 16, so we end up getting 16 times 3. Yeah. So now let's repeat this one more time for, not one more time, for each of these 4x4 squares. Well, 4 is not less than 2, so we're going to have to divide each of them. And then we're going to color in the upper left corner for each of them. Well, each of these upper left corners is going to be 2x2 since we just divided a 4x4 square. So we're going to end up with 4 times 9. 4 times 9 in terms of area. And I'll go ahead and color in all those little squares for your viewing benefit. Okay, in the next step, we have all these tiny 2x2 squares. Well, if we go back to the instructions, well, 2 is not less than 2, so that means we'll have to go through this process one more time, where we divide each of these small squares into even smaller squares of 1 by 1. And what we'll have is we'll end up with a bunch of 1 by 1 squares. In fact, we will have 27 of these tiny squares, because, I don't know, the way I'm thinking of it is because this corner kind of has 9 of these small squares, and that's 9 times 3. But anyway, you can also go ahead and count them. I'm sure you'd have time on the ACSL. But anyway, I'm not going to keep on torturing you guys by putting together all these little squares. We're just going to end up with plus 27 here, or 1 times 27, whatever. So I'm sure you could go ahead and add those numbers if you really wanted to, but that's the end for this lesson, and that's going to be the answer, whatever that number ends up being. Ask Noah. So there we go.